Good morning, class. God bless you. How are you all? Class, I'm a bit anger on you. You know why? Because very few of you are sending back your exercises and assignments which I'm giving you daily. Class, if you will not understand and cooperate with me, I will not be able to explain you further concepts or the coming topics. So please study, understand them, and solve your exercises daily. Today's topic is another group of definitions and concepts which are very simple but very important when we calculate chemical calculations. And the topic is gram atomic mass, gram molecular mass, and gram formula mass. Before I get into the definitions, let me revise you or let me sum up the whole story of defining and understanding compounds. So compounds are those chemical species or substances which are formed when atoms combine chemically in a fixed ratio by mass. And how they combine? They form their types. So the types of compounds are classified on the mode of their combination. Ionic compounds are formed when atoms are ionized, and atoms are ionized when they gain or lose electrons. Sodium makes its cation when it loses electrons, but chlorine forms its chloride ion when it gains electron. And when atoms are ionized, they start attracting each other. You know, there is a universal force of attraction between oppositely charged bodies. So the ions are gathered and they form a tight packing, which is the three-dimensional packing. So in this arrangement, each ion is equally attracted and surrounded by oppositely charged ions. So I cannot select or pick a single unit of sodium and chloride ions. So ionic compounds are a three-dimensional package of oppositely charged ions, and ionic compounds are formed which are made up of ions. This is not the case of covalent compounds. When atoms combine by sharing their electron pairs, they form covalent compounds. You see, in a molecule of water, you know water is a compound, covalent compound, and when atom of oxygen makes bond with hydrogen atoms, you see this red ball is the electron of oxygen which is shared between hydrogen atoms with a blue cross. You see, these two electrons are mutually and equally shared between oxygen and hydrogen, making a single covalent bond. Another bond is formed with oxygen and another hydrogen atom. You see, hydrogen molecule is the combination of two atoms of hydrogen and one atom of oxygen. And all three atoms are living together as a single unit. You see, the same is the case of oxygen molecule, in which two atoms of oxygen are chemically combined with a double covalent bond. When I compare the unit structures of ionic compounds and covalent compounds, the unit of ionic compounds is the formula unit, which is the simplest whole number ratio of ions present in the ionic compounds. For example, sodium chloride, which I showed you, and potassium bromide and magnesium bromide, in which oppositely charged ions are rationalized and the simple whole number ratio is represented in their formula, which is called as formula unit. But covalent compounds unit are represented as molecule. Molecule is made up of atoms chemically bonded by sharing of electrons, as the molecule of water, as hydrogen or methane. After comparing and revising the basic definitions, now we come on the main topic, that is gram atomic mass. When I express atomic mass in grams, it becomes gram atomic mass, which is also called as mole, the very important and coming topic. You see in the box of hydrogen in the periodic table, 1 is written. That's relative atomic mass of hydrogen. When I express this mass in gram, it becomes 1 gram. So the atomic mass of hydrogen when expressed in grams is called as gram atomic mass, and when gram atomic mass is calculated, in fact we are calculating the molar mass. Same is the case of carbon. You see in the box of carbon, group 6, 12 is written. When I represent this mass in gram, I am calculating the molar mass or gram atomic mass of carbon. Same is the case when I represent the molecular mass of any compound or element in grams. It becomes gram molecular mass or molar mass. I see the molecule of hydrogen consists of 2 atoms of hydrogen chemically bonded. So when I calculate the mass of the whole unit, I have to calculate the masses of both of the hydrogen atoms. So I add 1 plus 1 to get 2 grams. Similar is the case when I calculate the molecular mass of water. The molecule of water has 2 hydrogen atoms and 1 oxygen atoms chemically bonded together. And hydrogen 1, 1 and 16 oxygen. When I sum up all of the atomic masses, I get 18. So 18 expressed in grams become 1 gram molecular mass of water, and this is also called as the molar mass. Same is the case when I use presentation or when I use the ionic compounds formula unit masses. When I express them in grams, I work with gram formula, again a mole. Now I see the atomic masses of sodium from the periodic table, and chlorine. Sodium goes 23 and chlorine goes 35.5. When I add them up, I get 58.5. And same is the case of calcium carbonate. Calcium carbonate mass needs carbon, calcium and 3 times of oxygen mass to get 100. And when I use gram, it becomes the molar mass of calcium carbonate, which is a very important and commonly used industrial compound, calcium carbonate. Now today's exercise is to work out the gram masses of the compounds given in the table 1.3 from your textbook page number 8. Just read the topic from the textbook thoroughly and watch the video again and again with the help of example. I'm sure you will be able to solve or to work out the gram masses of the compounds mentioned in table 1.3. Take care class, God bless you, and I will be waiting for your daily assignments. See you tomorrow.